okay, so what is electrolysis? Well, let's say I've got some sodium chloride, but we don't actually we want to reverse it. We want to have the chlorine. So with the reaction I just talked about just a moment ago, I guess what's happened is the sodium has reacted with the chlorine, which was a Cl2. I've simplified it. I didn't go into the dot cross diagram of ionic compounds, and you get NaCl, sodium chloride, which is standard table salt. So that's what the reaction is. Now we're going to think that how can I reverse the reaction? What if I wanted to go back the other way? I want to separate sodium and chlorine. Well,
so what you have, let me just get this right. So this here, the sodium chloride, is this the positive sodium and the negative chlorine, right?
Hang on a second. Sorry, I'm just trying to find my videos. Oh, right, yeah.
Yeah, I understand.
So that's why we call this chloride is the negative ion, and that's why we call sodium chloride, because we're literally listing the ions, really. So yeah, sodium chloride actually is a positive ion next to a negative ion, but we call it sodium chloride, and we write it like that. So we're trying to reverse it now. Well, if it is that because ionic compounds are made up of positive and negative ions, well, in theory, we could. Let me just move this label out of the way for a moment. I'll put it underneath. Let's say that and let's lock it as well. Let's say that I made a strong positive charge on the left. So I don't know, I made a big piece of metal. Actually, I'm going to fix it like that. Oops. And one here. Let's say we had this really positively charged and this really negatively charged. So that would be quite good, actually, because you could then have all the chlorine would move over to here, because all the chloride ions would move over to here. And then what they would then do, well, this is what would happen. In theory, you would have you'd have the Cl minus ions, the chloride ions. They'd be moving over to this electrode here, which we call the anode. And well, you get two lots of them, and then they would combine together, form chlorine gas, and then give the electrons, two electrons, to that bit of positive metal, and that positive metal would absorb the electrons and then put them around a circuit or something like that, right? So this whole thing could be connected by a battery, right? Let me get this the right way around. Yeah. So, and then likewise, you'd have this side of it, which we call the anode. No, sorry, the cathode. Just did the anode. The cathode, which is the negative one, and that one would do the opposite. You'd have the sodium ions, and then it'd actually be taking an electron. It would be attracted to the negative one because the sodium is positively charged. And when it gets there, there's all these electrons stuck onto the cathode, and then it would produce sodium. So that's essentially what electrolysis is. But the problem is this wouldn't work in its current state. So at the moment, we need to do something else. Can you work out what we need to do? So basically, because this is a solid, this is like sodium chloride. So sodium chloride is generally is solid at room temperature. In fact, you'd have to melt it. You have to heat it up ridiculous temperatures. So if I did melt it, then these ions are able to flow, and then I really could get the negative ions moving over to the positive electrode, the anode, and then I would collect my chlorine gas, and likewise sodium go to the negative, and I'd be able to collect my sodium metal. So that would work. I could melt it, and then all this would be liquid, and that would work. Now, another way you can do it is you can dissolve it. So electrolysis can happen. So first of all, we should summarize then. Let's just summarize the points here, and I'll pause the video while I just summarize those points. So when you dissolve ionic compounds, the ions separate and move around independently. That's what happens if you dissolve some salt in water. Then the sodium and the chloride ions move around separately within the water. When you then evaporate the water, they all attract back to each other, and you have regular salt. But whilst they're in the water, then they are able to move around independently. So it makes a lot more sense if you're going to do electrolysis of salt, sodium chloride, and then to dissolve it, because it's a lot more energy efficient than to melt it. So what I was saying, just as I paused it, is to think about this, because we know that for electric current, we say is the rate of flow of charge, and so we need the ionic compounds to be able to, the ions, I should say. I shouldn't say the ionic compounds. Let's say the ions in the ionic compound need to be able to flow. That's probably a better way to phrase it. Yeah. So that's the basics of the fundamentals of electrolysis. So it gets a bit harder though. I'm just going to pause the video.